day everyone, welcome back to my channel. Our most essential learning competency for today is differentiating sequences from series, and of course solving problems involving arithmetic sequence. Okay, what is a sequence? A sequence is a list of numbers which follow a specific pattern and order. The individual elements are called terms. Say for example, we have 3, 9, 15, 21, and so on. Okay, so this one is an example of a sequence. Take note that the terms are separated by comma. Now, if you want to make this a series, this one will become 3 plus 9 plus 15 plus 21 plus 81. This one is a series and this one is a sequence. Okay. Now, there are two kinds of sequences. We have arithmetic and of course geometric. We will be discussing first arithmetic sequence. Okay. A sequence of numbers is called arithmetic sequence if the difference of any two consecutive numbers is constant. Say for example, we have 3, 9, 15, 21. For us to be able to identify this as an arithmetic, we need to get first the difference of these two consecutive numbers. So you have 6 and 6. Now, this 6 and 6 is what we call the D or the common difference, this one. And here is of course the number of terms. A sub 1 is the first term and A sub n is the nth term. Now, if we are looking for the sum of the n terms, we will be using this formula. Okay? So you can use this formula or this one. Let's take example 1. Find the 8th term of the sequence 25, 21, 17. So we are looking for A sub 8. Let's give first the given. Identify the given. So we have here the D. How are we going to get the D? 21 minus 25. And then 17 minus 21. So this one is negative 4, this one is negative 4. So you have negative 4 here as the common difference. What else? Our A sub 1 is also given, and that is 25. Okay. Our N is also given, and that is equal to 8. So we are now ready to solve for the A sub 8. Or the 8th term, that is equal to 25 plus 8 minus 1 times negative 4. So this is equal to 25 plus 7 times negative 4. So our A sub 8 is equal to 25 minus 28. Our A sub 8 is equal to negative 3. Example number 2. In the sequence 2, 5, 8, 11, what is the sum of the first 20 terms? So we are looking for S sub 20. Now, we have A sub 1, that is 2. Let us identify the D, that is 5 minus 2, that is 8 minus 5. We have 3. We have 3. So therefore, our D is 3. And then, our N is, of course, 20. We are now ready to use the formula for the sum. The sum has this formula. So, S sub 20 is equal to N over 2. That is 20 over 2. 2, A sub 1 is 2 plus N is 20 minus 1, and our D is 3. Okay. So, S sub 20 equals 10, 4 plus 19 times 3. Okay. So, the sum of the first 20 terms, we have 10 times 4 plus. This is 7 carry 2, 57. So, we have S sub 20 equals 10 times 61. And the sum of the first 20 terms of this sequence is, of course, 610. Example number 3. The 8th term of the sequence is 42 and the sum of the first 5 terms is 35. Find the 10th term of the sequence. So we have A sub 8 is 42. And then we have S sub 5 is 35. And then we are looking for the 10th term. Okay. So we need to produce two equations here because we have two given. We cannot identify yet the A sub 1 and of course the D. But we are certain that of course this one is an arithmetic sequence. So we have here A sub n is equal to A sub 1 plus n minus 1 D. And the other one is S sub n is equal to n over 2 to A sub 1 plus n minus 1 D. Okay, so we can use this now. This is A sub n, that is A sub 8. A sub 8 is equal to A sub 1 plus 8 minus 1 D. A sub 8 is of course 42. Equals A sub 1 plus 7D. So this one is equation number 1. For equation number 2, you have S sub 5 is equal to 5 over 2 to A sub 1 plus 5 minus 1 D. So S sub 5 is 35 equals 5 over 2 to A sub 1 plus 4D. Okay, so you have here now 35 equals 5A sub 1. This one is, of course, 2. That is 10D. This one is equation number 2. Let us solve now this system of linear equation by multiplying the first by negative 5. So we have 42 times 5 is 10 carry 1, 210. It's negative 210 equals negative 5A sub 1 minus 35D. This is 35 equals 5A sub 1 plus 10D. So we can cancel this. This one is equal to negative 25D. And this one is equal to negative 210 minus 35. We have 5. This one is 0, 10, 7, 175. Okay. Dividing both by negative 25 by negative 25. Our D here is equivalent to 7. Okay. So the common difference is of course 7. We can now find for the A sub 1 so that we can solve for of course A sub 10. So I will be using the first equation. This one is 42 equals A sub 1 plus 7D. So we have 42 equals A sub 1 plus 7 times 7. Okay. So we have 42 equals A sub 1 plus 49. 42 minus 49 is equal to A sub 1. A sub 1 is equal to negative 7. Okay. Solving for A sub 10 now, we have A sub 10 is equal to A sub 1 plus n minus 1D. A sub 10 is equal to, this one is A sub 1, negative 7 plus 10 minus 1 times 7. Okay. So A sub 10 is equal to negative 7 plus 9 times 7. So A sub 10 is equal to negative 7 plus 63. And of course, our A sub 10 here is equivalent to This one minus 7, that is 56. Example number 4. Insert 3 numbers in the sequence 9, blank, 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 45 to make it an arithmetic sequence. So we have 9, blank, 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 and 45. Okay, so our a sub 1 is 9. And our a sub 5 is 45. Okay, so we do not know yet, of course, our D. So let's find it. So we will be using, of course, a sub n is equal to a sub 1 plus n minus 1d. So a sub 5 equals a sub 1, 9 plus 5 minus 1d. A sub 5 is 45 equals 9 plus 4d. 45 minus 9 is equal to 4d. So what is 45 minus 9? 45 minus 9 is 36. Okay, divided by 4, divided by 4. And our d is equal to, of course, 9. 9. So our d now is 9. We can now insert here. 9 plus 9, it's 18 plus 9, 27 plus 9, 36. Plus 9 is, of course, 45.